A sketch a function that has following properties. So we need to cater this, but before, let's check how many conditions are there. 1, 2, 3, 4, 5, 6, 7. Right. So f of 0 is 0. What does it mean? That the our function satisfies this coordinate or it passes through 0 comma 0, right? For x greater than 0, f of x is less than 0. So what does this mean? X greater than, so on the right hand side, on the right hand side of the origin, f of x lies below x axis, right? Next is for x greater than 3, f dash is greater than 0. So what does this mean? Greater than, it means it's a rising slope, right? It's a rising slope like this, not like this. Okay, so it's a rising slope. Then you have f dash of negative 3 is equal to f dash of 3 is equal to 0. It means what? Dash means derivative. Derivative is 0. It means it shows the stationary points. But what type of stationary point? That is not being stated. Next comes for in this range, okay, your f dash is less than equal to 0. So less than means it will be a falling slope, right? And equal to 0, it means it can have a point where the tangent is horizontal, or there can be a point where your f dash is equal to 0. So this shows a falling slope, and there can be a stationary points. Why I'm writing the meaning of each and every condition? Because I have seen the student find difficulty in decoding it. Okay, and the question will be similar, and the question that is expected at the end day will be similar. So try to write it down after the session, the meaning of each and every, and then go towards the plotting. As x tends to infinity, f of x is 0. So it means at positive infinity, your f of x is touching your x-axis, right? As x tends to negative infinity, it blows up on the negative infinity side. Okay, so let's start the graphing of it. So I'll start in the reverse fashion. Reverse in the sense 6 and 7. So it is coming from negative infinity, right? As x is on the negative infinity, it is coming from down, right? And it passes through origin that's given to us, and then it is said, so this condition is taken care of. This condition is taken care, it's coming and it is passing through origin. Then what is being said, as x tends to infinity, so it means it's something like this. Either the graph will be like this or the graph will be like this. We need to decode that for the sixth condition. It will be one amongst two. So then it says when it's between negative 6 and 3, f dash is less than 0. So you have a negative 6 and you have a 3. Right? It's less than. It means it's a falling slope. Right? So how does your falling slope look like? Does it look like this? No. The falling slope looks like this green one, right? It looks somewhat like this because it passes through the region. So it will look like this. It's a falling slope. Okay. So for the fifth condition I have drawn with green, and it's at the fourth says at -3 and +3 it is the derivative is 0. It means there is a turning point over here. Okay. So at -3. So we need to include a -3 as well. So at -3 there is a turning point. But it says that it's a falling slope. So it means the turning point is a point of inflection. Like this. So concave down, then a concave upward shape. Okay, like this. It's going down. Okay. So we have taken care of this one. Now it says when f dash is greater than 3, it's a rising slope. So it will be like this because and it touches your x axis, right? It's like this. So this is taken care. So this is not there. This yellow part is being erased. And this is not there. This is also not there. Now, let's come from as x tends to negative infinity, f of x comes from negative infinity. So the graph looks like this. It goes up, it comes down, then it changes the point of inflection. Okay.